Morning, children. Today we will be discuss about in the locomotion and movement chapter. There will be, very well, in the muscle myofibril we have some such contractile proteins are there, right? They will be called actin, thin, myosin, thick filament. So you know very well actin, myosin, actin, okay, myosin, like that. I band, you know very well. So like this, Z line, Z line, these two are thick, okay, thick filaments, thin filaments. This is called myosin, this is called actin, like that we discussed. So that one, these actin structures we are going to discuss. So this is a myosin. So this one is, this end is attached with the, which one? Actin. So this actin, myosin, very important. This heads opposite end of the filament. See, this is a, here it will be, and here it will be attached, here it will be attached, here it will be attached. So they will be move, they will be relaxed, they will be like this, contraction, relaxation, like that. So this one, this myosin filament, if you see, that will be made with, that is called meromyosin. Okay, the two regions are there in the meromyosin. See, now here I am drawing, this is a meromyosin. This particular part is head region. What is called? Head region. Head region, what we can say? The head region we can consider as heavy meromyosin. What is called? This head region, what you can consider? This is ATPase enzyme. This is helpful for binding actin, binding site. What is called? Heavy meromyosin, this head. And the tail region, this particular region is called tail region. This is called, what is called, light meromyosin. So head meromyosin, light meromyosin, so tail. So head consists of actin binding site and ATPase. So ATP binding site and ATPase is there. So like this, the heavy meromyosin and light meromyosin will be there. Okay, children, once we will see the picture, then you will get clarity about what is called this, what is called actin and myosin. Okay, actin and myosin, we will get clarity. Okay, observe very careful. So this is a thick, okay, thick filaments. So these are thin filaments, right? So it's a Z line, this line is a M line, this one you know very well, A band means thick, so thin. Now they will be attached here. This myosin at head attached to the actin, this is called actin, right? Thin is actin, thick is heavy, what is called heavy meromyosin. So now that one we will see. What is this one? This myosin. Thick is called myosin. So now myosin part we will see. See now the myosin part. This is the myosin. So the myosin like this, and the myosin have the structures like this. Here it will be bind to actin. So like this here, this particular. So now this particular area, this is called HMM, heavy meromyosin. This particular area is called tail, means light meromyosin. Here one enzyme, what is called ATPase enzyme. So this total structure is called, what is called, meromyosin, myosin, thick filament. This is called thick. What about thin filament? So thin filament, this one, this actin, thick means myosin, you know very well. Now actin we will be discussed. Thin actin, very simple, you see, like this, very simple. So these are actin. So now you see, these are the structures, these are round structures like this. Okay, so this is a globular actins, G actins. This is G actin. This all globular actins togetherly form. It's a filament like that or not? So G actins means round like this. All G actins togetherly form, what do you call? Like this circle. This is called filamentous. So like this will be filamentous. Now inside the thread-like structures, these thread-like structures, this is called what is called tropomyosin. Tropomyosin, and here they are occasionally here, 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 like this. The locations are there or not? Here some contractile proteins. They are called tropionin. What is called tropionin. So this one. So where this head will be go and bind here, this particular area. So there will be bind like this. Which one? The myosin head, this particular part. So this particular, they will be contract. Okay, they will be bend like this, means it will be move like this. So like this, what is called actin, the myosin, actin made with what? 4. G actin togetherly form F actin. G means globular actin togetherly form which one? Filamentous actin. And in this thread-like structures are called tropomyosin, and these locations are called tropionin. So 1, 2, 3, 4. So here 1, 2. Heavy meromycin consists of ATP and binding sites of the actin. So like this, there will be the contractile proteins are there in the muscle. Okay, that is a very important. Okay, now come see, I said or not, this is a actin filament. F actin, G actin, globular actins. So F actin is a polymer of monomeric G actins. All G actins togetherly form F actin. Tropomyosin, tropionin are regular proteins, so regulatory proteins. So tropomyosin, tropionin, actin and myosin are very useful for the muscle contraction. So actin, this is the actin, thin filament, is a thick filament. So mechanism, what is the mechanism? It will be pulled. So the bend, this actin myosin bend in the sense actin will be moved that side. So this one proposed by Huxley and what you called who proposed this theory? Huxley and Nieder-Jerke. So this will be under control of central nervous system, the neurotransmitters. So ATP will be by converted into ADP. So the theory is called sliding theory. Now calcium tropionin, like said, there will be one mechanism is there. So if you observe very carefully, that mechanism will be discussed now. Okay children, now very simple mechanism, very easy. Theory is, this theory is called a sliding filament theory. What is called? Sliding filament theory. Very easy theory, very simple theory. Okay, so now we are discussing about sliding filament theory. Sliding filament theory. Okay, so now observe very carefully. Very simple. So this is the which one? The actin, right? Actin. So this is the myosin. Okay, myosin. So did not bind till. What is there here? It will be there. ATP is there. So these are enzymes. Second step, what will happen? So this is the actin, right? So second step, this is a myosin. Okay, this one will be bind. So here ATP as enzyme is there, then ATP will be converted into ADP and phosphate. Then third step, what will be happen? Phosphate will be bent like this because it is be bended. So it bended means the ATP will be, this actin will be moved this side, it will be bent like this, it will be. So the third step, again this will call power stroke. So again it will come to normal position. Again ADP will be added to which one? Inorganic phosphate. Again what will be takes place? ATP. So what is going on? Whenever the energy utilization is going on, there the bending will be takes place. So like this sliding filament. For example, This is a what you called the actin. This is a myosin. When it will bend, it will move this side. So when it bend, it will be move this side. So this is called a sliding filament theory. So how it will be mechanism, you know very well. So this is the our sarcomere. In the sarcomere, what is going on? You see, this is the high bands. This is the light bands. So thick filaments, thin filaments, thick filaments, okay, thin filaments. So now it will be bent like this. It will be. So it will be like this. So at last what will happen? So now you see the thin filaments will not, thick filaments will not move. Then who will be move? Who will be move? Thin filaments only will be move, overlap each other. See now overlapping. So it will be contracting. Who? Because of the which one? The thick filament. So you know it will be overlapping. It will be overlapping. Next, another one. So next, like this. Okay. So thick filaments constant. Thick filaments constant. Then who is moving? Who is moving here? The thin filaments are moving. So contraction of thin filaments. Thick filaments are constant. Thick filaments are constant. Thin filaments are constant. So because of these heads, here what will be binds? Heads will be, there will be movements will be takes place. So first, how ATP will be converted to ATP and inorganic phosphate will be released. Release because the inorganic phosphate will be formed because of the ATPase enzyme that is present in the which one, the theory. So here ATP is there, this is a myosin head binded to the now where this one, here one contractile protein is there or not, tropionin. So this particular area, so tropionin go and bind with the which one, you know very well, react with the calcium. Then this site will be free, then they will be, which one will be bind, myosin head will go and bind here. So here like this. So ATP will convert into ATP, then bending will be takes place. It will be repeatedly takes place until contraction, maximum contraction. Then once the relaxation happened, what will happen? Again tropionin will be come here, then it will become to normal position. It won't touch, it will become to normal position and it will be relaxed. All will be relaxed. And this calcium, where the calcium will be? The calcium will be there in the which one? Endoplasmic, what do you call? Endoplasmic reticulum, it will be there. So it will be endoplasmic reticulum means in the muscle terminology what you call smooth, what you call sarcoplasmic reticulum. The calcium is the sarcoplasmic reticulum is the calcium reservoir. So like this, what you called the sliding filament theory is there. It's proposed by, who proposed this one? Who proposed? Huxley. And Huxley, here is there is the ATP sites. Okay, here ATP here. So these are myosin heads. It's a thick, it's a thin, actin, it's a thick. What are the parts? Heavy myromyosin, light myromyosin, head region. So nothing but head, region, tail. So this is a myosin, thick. It is thin, actin. Actin made with what? Globular actin, altogetherly form filamentous actin. Okay, filamentous actin. And they have sites, what is called tropionin. It will be tropionin, and this is a thread-like structure, what is called tropomyosin. So in the this cycle, what we have to remember is ATP is plays a very important role. Energy is very important. So this kind of steps will be takes place. So this is called what is called this theory? Sliding filament theory. See now, calcium ions, when the calcium ions release, they will be bind to the tropionin. Okay, relaxation time, tropionin will go and bind to the again active sites. So when the impulse is there, then only tropionin will release and bind to calcium. Then active sites will be, the site will be open to bind the myosin head. So like this, what you call the sliding filament theory will be there. So what is this? It's called actin. It's called actin. It's called myosin head. Okay, myosin. So myosin. So this is myosin. So bending or not, like this bending. So it is moving like this. It is moving like that. So again ATP will bind to. Again what will be formed? ATP. Here what? Releasing ATP. ATP will be converted into phosphate. Here ATP and what called inorganic phosphate, because force required, energy required to form that. So like this there will be what you call the theory name is sliding filament theory will be there. So this theory proposed by who? Huxley and Huxley. Okay. So muscle contraction means you know that first what happening? The thick filaments. Which filaments? Thick filaments are there or not? So thick filaments, thick filaments. So this is the eye line. So now you see what is contracting. Contracting means this is actually like this. But muscle contraction time the thin filaments are like this. Okay, like this contraction. This eye band, jet line, jet line. Which one? The thin filaments only moving. Thick filaments are constant. Just by the help of myosin they are bending. That's it. But the thick filaments not at all moving. Only thin filaments are moving. Okay. In the next class we will be discuss about the appendicular skeleton system and axillar skeleton system will be discussed. Why? Because the appendicular skeleton system means what, and axillar skeleton system will be means what, and what you called the schematic presentation of muscle contraction also will be there. What will be there in the schematic presentation of muscle contraction? First, muscle contraction is initiated by central nervous system. Then release of acetylcholine at the neurotransmitter junction. Acetylcholine is very important. So then triggers the release of calcium ions. So calcium ions is important from a sarcoplasmic reticulum. Then calcium binds to the, which I said, troponin. Then calcium is combined with the troponin. Then myosin binding site, the myosin binding the actin site. Then myosin head executes the power stroke. Then actin filament slides. Actin filaments are slides over the myosin head. Okay, okay, like that. Signal from when the central nervous system stops the impulse, then again troponin will come to normal position. Calcium will go to the sarcoplasmic reticulum. Then relaxation will be takes place. So this is a theory. This theory is called what is called the sliding filament theory. The sliding filament theory. Okay, who proposed this sliding filament theory? Huxley and Rolf Niedergerke. Niedergerke proposed the Huxley. Okay, who proposed it? Huxley. Huxley. And who is that another scientist? Niedergerke. Who is that one? Niedergerke. Niedergerke. The scientists proposed this sliding filament theory. So if you see in the textbook pictures, easily you will be understand. One is cross bridge formation, then power stroke, cross bridge formation, power stroke, and what you called cross bridge. Then crocking of what you call cooking of myosin will be takes place. That picture also will be there in the textbook clearly. So next class, what I showed. So there will be skeleton muscle fibers are there, and skeleton systems and its functions. What are the skeleton systems? Okay, and what are the types of contractions will be there, and what are the functions of skeleton system? Okay, you know very well. How many types of skeleton systems? Appendicular, appendages. So you know humerus, radius, alla, carpals, metacarpals, phalanges, like that is there or not? Then axial skeleton system. Okay, the skull. Okay, vertebral column. Okay, ribs and pelvic and pectoral girdle. These all are there. Tomorrow will be discuss each and every system and how many bones. You know very well. Total 206 bones. Okay, it will be how the 206 will be formed. Will be discussed in the next class. But up to that, this theory is very important. Compulsory you should have to practice sliding filament theory. Definitely bits will come, and also that is called useful for exam point of view.